Most developers think that software engineering is just about memorizing syntax. In reality, it is about designing architectural leverage. Consider this fully autonomous multi-platform social media engine. From input to deployment across multiple networks, the entire system executes in under 55 seconds. The sequence initiates without a single copied line. A user simply changes a database status to approved, and a webhook instantly fires. That raw payload flows directly into a large language model engine, automatically reformats itself for distinct environments, and strikes multiple social APIs simultaneously. True system design abandons isolated manual scripts in favor of this: zero-friction, webhook-driven interactions that run continuously in the background. Achieving that 55-second deployment speed requires precise planning. You can build this exact pipeline in under 2 hours, provided you follow 3 rigorous architectural models. First is paper-first system design, which demands strict schema definitions before a single line of code is written. Second is treating artificial intelligence as a functional peer, rather than relying on it as an unstructured black box. Third is the rule of 3 for systemic modular automation. By reverse engineering this specific pipeline, you will see exactly how to transition from brittle manual coding to designing highly scalable autonomous architectures. We begin by freezing the completed pipeline and isolating its origin point, the Notion database and its outgoing webhook. This relies on the paper-first engineering rule. Logic and constraints must be mapped completely dry before any live data is allowed to move through the system. Here, the Notion schema acts as a strict input constraint. Every field, whether text, status, or date, is locked firmly into place as a foundational pillar. Defining these variables upfront guarantees that the outgoing webhook payload extracts cleanly and remains mathematically predictable. When engineers fail to map these constraints, they are forced to write complex, error-prone parsing scripts later in the pipeline to clean up messy inputs. Our clean extraction ensures the receiving orchestration engine requires zero manual parsing to understand the data. Front-loading your constraint design at the absolute beginning of the pipeline is the only reliable way to prevent cascading logical failures downstream. We track that pristine webhook payload as it routes securely into the N8N logic environment. This architecture utilizes a specific AI component for processing, the Claude 3.5 Sonnet API agent node. A common mistake is using large language models as a crutch to solve poor foundational logic or disorganized data. In this system, the AI serves a strictly defined role. It acts as a stateless, deterministic peer, executing specific data transformations based on rigorous prompts. The raw idea enters the AI agent node and immediately bifurcates into 2 distinct formatting paths. Path 2A instructs the model to restrict the payload, generating a highly optimized 280-character post designed for X. Simultaneously, Path 2B commands the model to expand that exact same core idea into a structured, longer-form professional post with strategic line breaks for LinkedIn. Confining the AI to this specific transformational role allows the architecture to dynamically handle varying space complexity across platforms, avoiding brittle, hard-coded formatting rules. Once finalized, both platform-specific text variants are pushed via an HTTP request directly into the Make.com ecosystem. This brings us to the architectural rule of 3. If a manual deployment is executed 3 times, it must be modularized and automated. While you could write a manual Python script to handle API posts, a decoupled, webhook-driven routing engine is easier to scale and maintain. Make.com acts as our centralized multi-channel distribution router, receiving the 2 distinct data blocks and directing them down separate parallel pipelines. Router Path A connects to the X API to execute the immediate publishing of the short-form post. Router Path B connects to the LinkedIn API, scheduling the expanded professional post for peak engagement hours. Using a visual routing engine like this creates a self-documenting architecture. The visual node structure inherently explains the deployment logic to any incoming engineer without requiring a separate manual. After deployment, the system briefly pauses. It waits for successful HTTP confirmation codes from both platforms, indicating the posts are live. We then initiate the final architectural leg. Make.com automatically routes those live URLs back to the original Notion database. This enforces the Boy Scout rule of software engineering. A process must always leave the environment cleaner and more updated than it found it. The system automatically updates the database status from approved to published and populates the fields with the live tracking URLs. Building this closed circuit completely removes the need for human intervention in state tracking, achieving true zero-friction autonomous operation. Zooming out, trace the continuous lifecycle of this architecture, from Notion to N8N to Make.com and back to Notion in a perfect closed loop. Successfully building an orchestration engine in under 2 hours is a product of pristine logical sequencing, not rapid typing. Principle 1. Paper-first logic defines strict constraints and eliminates upstream debt. Principle 2. Treating artificial intelligence as a deterministic peer isolates complex data transformations safely. Principle 3. Automating repetitive distribution tasks via visual routers completely removes manual cognitive load. Mastering these 3 mental models elevates a builder from someone who simply writes isolated scripts into a true systems architect. Audit your own daily technical workflows immediately. Identify your single most repetitive task and map out the required API endpoints on paper today. Stop using AI merely as a conversational chatbot. Use it to build your own automated orchestration engines. Invest the time to build the architectural engine once and let it run forever.